Hello, and welcome to today's webinar, Modernize ZOS Application Infrastructure Operations Analysis with RMF and SMF. Thank you for joining us today. We have packed a ton of helpful insights into this webinar. We encourage you to submit questions throughout the event via the questions section in the GoToWebinar control panel, and these will be addressed at the end of the webinar as time permits. We will be recording the presentation and will send you an email with the link and the slide deck after the webinar. Our presenters today are Brent Phillips and Todd Havicost. Brent Phillips is the Managing Director of IntelliMagic in the Americas. With a history of technology entrepreneurship, he started the IntelliMagic U.S. operations in 2005. Brent has been working with enterprise software for over 30 years, starting in IT operations while in university, and later as a systems programmer. He has been with IntelliMagic for 12 years and is now responsible for the IntelliMagic business in the Americas region. Todd is a senior ZOS performance consultant for IntelliMagic. His primary area of interest over the course of his 39-year IT career has been ZOS systems performance. Before joining IntelliMagic, Todd spent 26 years at USAA in a variety of roles, including responsibility for leading their very successful mainframe software cost reduction project. Having been thoroughly impressed as a customer with the visibility IntelliMagic Vision provides into ZOS systems infrastructure, he joined IntelliMagic last year and now helps customers leverage that visibility with particular focus on reducing their MLC software expense. I will turn the broadcast over to Brent to get us started.
Okay, thank you, Morgan. Thank you, everyone, for joining us this morning or this afternoon, depending on your location. Very happy to spend some time with you today. As Morgan said, we do like questions, and everybody is muted by default, so please submit some questions as we continue through the session today, and we'll do our best to address it. We do have a lot of content, so we might not get to all of them, but I'm going to start out the time this morning by talking a little bit about what we mean by modernizing how we use and understand RMF and SMF. This is, of course, focused on the performance and capacity planning kinds of tasks. You can do other things such as security monitoring out of SMF and so on. That's a different kind of scope than we have this morning. So we're going to cover some of that content and then move into a technical demo. We like kind of the show and tell approach. So Todd will use a couple of slides to talk about the different areas that he's going to speak on, and then swap over and show you a live view of our approach with our product, which is named IntelliMagic Vision, on how we modernize how you understand what the data means for your applications on your infrastructure. And in an hour, we don't have time to give a full scope of everything across the infrastructure that we can show. So we thought it'd be most interesting to focus on some of the newer data sources that have emerged over the last few years, such as some of the new the EDC things, for example, some of the things on this list. So Todd's going to focus on that, and hopefully that's interesting for you, and we'll hopefully have some time at the end to address your questions as well. If we don't get to your questions, go ahead and submit them. Somebody will get back to you after the webinar with the answers if we don't address it for the audience at large. So why modernize how you use RMF and SMF? Of course, the way I like to explain the overall objective is in terms of effectiveness and efficiency of delivering the services that your application requires, or you can call that availability. Availability, of course, means more than just disaster recovery operations. It's are the applications available to the end users on a continuous basis. So how effective are you at doing that, and how efficient are you at doing that? From an effectiveness point of view, continuity, of course, is the overall objective, and that to really get good at that is the ability to predict and prevent disruptions that are caused from the infrastructure itself, from different bottlenecks or constraints. And RMF and SMF have a lot of details within them that can facilitate that, and that's one of the objectives of modernizing our approach to the RMF and SMF data. Whether you find out about a problem in advance of it affecting the production users or not, it's got to be solved. And this is the most common use of the data today after a problem has happened, to use it for a post-mortem. But we believe that it can actually be predictive if you approach it in a more modern way, and it can help in the problems that are happening at the moment as well, to restore the service levels for those things that were not predicted in advance. So it's not just for a post-mortem after the problem. And efficiency is also something that's really coming up in the use of the data if you approach it in a new way, for example, by easily understanding the costs of the infrastructure, particularly the software costs, but there's also hardware costs that can become visible more easily when you modernize your approach to the data. And then just in the staffing level as well. Everybody knows there's an issue with the skills gap on how do we bring more people onto the ZOS platform and up to speed on what it means. How do we bridge the different silos of expertise together more easily? And I list job security here as well, just because if the more efficient we are at providing these and delivering these availability levels for our production applications, the less likely it will be outsourced or something of that nature. And that's kind of our approach to modernizing this. We don't, in 12 years, I'm not aware of any of our customers that have actually laid off people because they've updated their approach and made it more efficient on replacing some manual ways of understanding the data. It's really about delivering availability more efficiently and more effectively, and doing some things that just cannot be done today when we're using the existing processes. So to achieve both sides of this equation, one way to look at it is how do we operationalize the data? This is our approach. By using some artificial intelligence types of techniques on the data, we can derive much better intelligence about what it means for your applications on your infrastructure. So that's the overall kind of picture of what we're after with what we're doing. And we do just like to point out how most sites are still using a process that was designed 4 decades ago on generating some, putting the data over to a PDB and generating some static reports. And here's a 4 decades old process. I used one of these in my Assembler 370 class in university. Still was amazed by the technology, but nobody's using this today, right? Because it's been outdated and far more efficient and effective ways to get the data into the computers. Same thing, phones. This is a 1980s phone. Nobody's using these kind of things. Well, what about the process for writing programs and generating static reports on what the data means? Even if you're using, you've updated and using some nice looking charts like these on the lower right here. I mean, that's a pretty good chart, much better than the table kind of views, but it can be a little deceiving on whether this is really a modern view or not. If you can't click on any of these items in here to drill down to what are the addresses spaces that are running on, to drive this MSU consumption, for example, or hover the mouse over it and have the legend pop up and see where you're at. So these drill down capabilities, the information that's included, any ratings. There's no ratings on here is for different kinds of metrics. Is it good or bad for this infrastructure, for this workload? These kind of things. No compare functions. So those are some of the things that you'll see as Todd does his demo a little bit later on in a more modern interface. Because really what we're trying to do is to, of course, improve the efficiency and the effectiveness of how we understand what the data means, or the questions that we're asking about the data. And that's an interesting way to position what we're after here. This is a quote by Kevin Kelly, it's really more profound than it may look in the first glance, but we should require our computers to deliver answers and position what we do as asking good questions and developing the strategy to remediate the risk or the problem, fix the problem, so on and so forth there. And this is what we're doing with our mobile devices, right? Siri or Google, you can just ask it. You don't have to go and do a lot of research manually and derive the intelligence. And really the question then is, why can't we do that with RMF and SMF to get better answers and make the computer tell us things. So what kind of questions are we talking about? This is a great example, and it's a very difficult question. Most of you on the call today probably do not have a way to get an answer to this question very easily. To understand across a large, complex environment, what should somebody focus on now as a performance analyst? Our approach with the data to be able to rate it will produce what we call exception tables. This happens to be one from for the coupling facility part of the infrastructure, where there's sophisticated ratings that are built in with some observations and recommendations and so on. And you can go from there to a summary, what we call a dashboard, then from the exception table to the dashboard to see at a glance many different metrics that are rated. And Todd will show you some examples of this. So this is a dashboard for Workload Manager, obviously. Each dot represents a separate chart, and the blue ones are not rated, but the relative size of the bubbles will show you some idea of balance, for example. But the other metrics are either green or yellow or red, and the bigger the yellow dot or the bigger the red dot, the more that particular metric has been violated, violating the thresholds that are set based on the infrastructure and the type of workloads those infrastructure components are running in most cases. From there, you can drill down and see, answer basically the questions of what metrics are relevant to this particular issue, and seeing them side by side in what we call mini charts, and then drill down further from there, building an intelligent path of where an analyst would want to go for each particular type of issue, including recommendations that can help in that skills gap area for somebody that's newer to the platform, or even for experts we find really appreciate the value of having this kind of intelligence built into the analysis. So how do we get those kinds of answers? It really comes from better analytics on the data. So you may be familiar with this term already. There's a lot of companies using this called ITOA, IT Operation Analytics. And I like this definition from Forrester Research, actually, which talks about using mathematical algorithms and other innovations to extract the meaningful information from the data. And in particular, the other innovations is something that we like to point out here at IntelliMagic, because it's more, to really get the value out of the RMF and SMF data, you need more than just statistical analysis of the data to recognize anomalies and see correlations in different metrics. That is of some value. But from our perspective, you get far more intelligence that's specific to the infrastructure when you apply ZOS-specific expert knowledge to the data, which is a form of artificial intelligence as well. And that's how you can get these better analytics. And artificial intelligence, there's a lot of different definitions of what that means. You can actually Google the periodic table of AI, which has a nice spectrum of the different types of AI that are out there. So in our approach of applying this expert knowledge to the data that's ZOS specific, you can get this predictive value and you can solve problems more quickly. And it's really these kind of things are being done throughout the organization, which is one of the reasons why Gartner Group has rated applied AI as the #1 technology trend for the second year in a row. So it's the idea of doing things that are not possible to do when you're relying on a manual way to understand what the data means. It's like having 1,000 pairs of experts continually assessing the data to surface what somebody should look at. So this is actually a pretty old diagram out, and you can find it on Wikipedia, of just the process of moving from the data that comes from, collected from the operational environment, transforming that into information, and then from information into intelligence about what it really means. How do you get some actionable intelligence out of it in order to deliver the service levels more effectively and more efficiently? Today, the process that customers use is mostly automated in terms of getting the static reports available. And of course, there's coding that's required for each new chart or each new metric, or really every new view. So that can take some significant time that most teams kind of struggle to find the time in order to support the newer records in particular. But once that coding's done, then you can obviously create all these reports, typically only once a day, rather than much more frequently throughout the day. And then it's a process of understanding what do these hundreds of different reports mean, and that's not automated, and it requires very significant time. I mean, if this is the process of really trying to find out what is the answer to these kinds of questions. And it's so time-consuming and requires so much expertise from many different silos of expertise that it's really not done until after a problem has already happened. And that's why the data is typically used only for the post-mortem of what went wrong. It's also used, of course, for long-term capacity planning and trending and so on and so forth. But we believe that this is an area of opportunity to get the computer to answer some of these questions for you to do things that are not possible to do today, specifically being more predictive and solving problems that are going on right now, not just the historical aspects. So again, the secret to being able to change the outcome of what you get out of the data is the ZOS specific expert knowledge automatically applied to the data and continuously surfacing different issues that somebody should look at. So over the 12 years that I've been doing this here at IntelliMagic, I mean, we've found a lot of different ways to apply ZOS specific expert knowledge to the data to change the result and classify the different areas here. I think for the sake of time, we're going to kind of skip over this, but you'll see these in the session. We have a whole presentation actually just on how we use this expert knowledge and to change in the process and the outcome. Ratings, I've mentioned these dashboards. We actually do some things to ensure that you get as few false positives as possible, and even more importantly, that you don't get false negatives when there's something really important for somebody to look at that doesn't get flagged until the production application and users are effective. So we can discard things that are really not significant workloads and so on and so forth. We have different types of thresholds. Again, there's a white paper on our site about our ratings and thresholds that goes into much more detail about dynamic thresholds and static thresholds and when each is used, so on and so forth. So I would encourage you to take a look at that if you have more interest in how some of this magic happens. So the overall objective, of course, as I said at the beginning, is to operationalize the data so that you can use it for new uses, so that you can get predictive views and avoid problems by seeing issues. And this is actually a sooner than real-time kind of scenario. We just tend to think of the RMF and SMF data as historical data only for afterwards, but it contains a lot of knowledge in there. And if you apply expert knowledge about what the different best practices that are in the red books, or expert knowledge about specific hardware components that are in use and what they're capable of, and when during your peak periods they're approaching levels where the service levels are going to be affected, where delays will be introduced into the applications, then it can become predictive data. And you can use it if you load some of our best practices are to actually load and process the data once an hour, for example, as opposed to every 24 hours that a lot of sites are still doing with their RMF and SMF data. And then you can see what's going on right now if there's some issues that people are calling about. We can also group the data together to segment the workloads by application or by a group of application workloads. And that can open up the use of the data for DevOps, for example, to easily compare and compute the difference on the infrastructure of the new version compared to the previous version in a test environment if they're running the same workloads, for example. We believe that ought to be a standard part of every DevOps organization. And we're going to be doing a presentation at the next Share in Providence on that topic. Or for a business application owner to be able to see, we have some customers that want to deliver this to the application owner to show them on a daily basis what's the infrastructure health for their particular application. There's other uses down at the bottom there of our version this summer is getting some new features in terms of the statistical analysis on the data. We're working with some customers on showback, chargeback issues, adding some additional capacity planning analysis into the product as well. So we just think there's a lot more out of the data than most people are able to realize based on the process that they're using. So you've seen probably our slogan there, availability intelligence. This is really what we're after, providing intelligence for you to be more effective and efficient in how you deliver availability for your applications from the infrastructure, actually resulting in actionable insights. We have over 400 currently of these insights that are automatically assessed and rated using the artificial intelligence that we build into the product. So one final concept here before we switch over to Todd is on how we deliver this. The best practice for us is to do it in a software as a service mode where your staff does not have to babysit the process and worry about the database and the daily processing and so on and so forth. So it's much easier to have that outsourced to the experts that are just focused on that, so you can focus your time on the analysis and strategy for what to do about different issues that come up. This also allows you to use some of our experts. We've got some very deep experts in many different parts of the infrastructure that are looking at data for different customers and seeing different situations. So a lot of our customers, for the sake of knowledge transfer, especially at the beginning of an engagement, or even on a ongoing basis, they'll get 10 or 20 hours per month to review with our experts what's going on in the environment. You can still install it on premise if you want. It doesn't have to be software as a service, but we find our customers will get much more value out of the product in this kind of mode. And it's probably a lot easier than you think to start getting intelligence out of the data. And we use this for a proof of concept as well if you want to send us data, and we'll talk a little bit more about that at the end of the session today. So at this point, I'm going to switch over to Todd, and we'll get more into the technical demo. Okay, Todd, you should have control.
All right, thank you, Brent. All right, so this is a list of the broad scope of ZOS infrastructure areas covered by the systems component of IntelliMagic Vision. The items highlighted in green reflect areas in which we implemented significant new functionality in the release that came out earlier this year. Customers that are relying on in-house developed legacy performance reporting systems like the ones Brent talked about earlier frequently indicate to us that they face challenges keeping up, particularly with the emerging technologies that are listed in the right-hand column here. So I'm going to spend the majority of today's demo covering many of these emerging technologies. Now, I'm focusing on systems technology today because that's my expertise, but IntelliMagic has been the market leader in ZOS storage analytics for more than a decade. So I'll begin with a few storage charts that reflect that deep expertise. And I'll also introduce the product interface, which can execute either as a browser-based web reporter or as a Windows client, which I will be using today. All right, so all areas of the ZOS infrastructure are integrated into this single interface, and they're represented by the viewpoints here in the lower left quadrant of the screen. So we see the various aspects of storage, systems, and virtual tape all integrated in a single interface. And then when a particular viewpoint is selected, then a set of focal points appears up here above that, and then those expand into a set of report sets. And when we select a particular report set, then the previews of all the reports in that report set appear here at the top along this top row. And the selected report is presented in the primary area of the screen. So this chart displays response times for the 4 storage frames in this environment for the interval that's selected here at the top of the screen. And these radio buttons represent various drill downs that are available into this data, as Brent talked about. So let's drill into the response time components for this particular storage frame. And in addition to the response time components, which are for the axis on the left, there's also here a total I/O rate reflected on the axis on the right. Since disconnect is the primary component of the response time here, let's drill further into the components of the disconnect time. And here we see it results, the disconnect time here in this situation results primarily from back-end drive reads, but it also consists of some contribution from synchronous copy. All right, then back to the response time chart. And then we can drill in by a number of different ways. We can drill in and look at the response times by subsystem ID or by storage group or even by volume. Now here's an example of the dashboard that Brent talked about earlier, which applies the embedded ZOS subject matter expertise, in this case to the top 30 storage groups for this set of metrics. So here, for example, there's a warning for pen time for this particular storage group. And then read hit percentage is an exception for this storage group. So let's drill into that. Now we see a set of time charts or mini charts that reflect all of those metrics for this particular storage group. So I can quickly compare and see the various metrics. For example, I can see here there's a very significant I/O rate to this storage group. So then the response time metrics are of interest to me in the read hit percentage. And here this is the metric that was read. I can drill into that and then have the detailed chart for that. Brent also mentioned that these are gathered, all these exceptions are gathered into an exception table. So here's an example again of the exceptions in this environment and various information about them. So, and then I can drill into any one of the charts from here. And so for example, this is that chart that we just saw a minute ago. So this is just a quick demonstration for both of the storage expertise and dashboards and exception tables. All right, so now we'll look at several areas of ZOS systems infrastructure into which IntelliMagic Vision provides the kind of visibility you need to effectively manage your environment. So we'll start out with SCRT and usage data. At a recent conference, Kathy Walsh told the story about the original IBM team that was commissioned to design the SCRT report. And this was in 2002, and at the time they were told that the life of this program was expected to be 6 months. Well, we all know that program's been around now for 15 years. It was recently rewritten last year in Java. It was originally written in assembler. It was rewritten last year in Java to support some additional IBM pricing models. But anybody that's used the IBM SCRT program is well aware that it's very good at telling IBM how much money you owe them based on the MSU consumption, but not very helpful at all in giving you information that could help you reduce that software bill. So IntelliMagic Vision is designed to give you that kind of information. All right, so here is here we see the peak MSUs for a particular billing month for each IBM product for the 4 processors in this environment. And right off the bat, we can see the differences in the various software products, which gives us an idea to the degree to which LPARs have been configured to have a less expensive software suite. From here, we can drill down into the peak hours for this particular product on this particular processor. And we can see how much higher the peak is than other values in the month. In this case, billing month. In this case, there's not much difference in those values. And also, quickly at a glance here, we can get an idea of what time of day do have these peaks been occurring? Are they in a similar time of day, or are they kind of all over the map? Here's that same kind of data, but now in tabular format. So we can see the top 20 peak hours for that product on that processor, and see the value, again, the MSU values, and see how much they differ. Now from here, then we can drill directly into the that 4-hour interval and see what workloads, what systems, what address spaces were responsible for contributing and consuming that CPU that contributed to that amount of MSU consumption. So we can see here, this is a system view. Let me go back for a second and let me look at the KEC view first. So here's the KEC view, and from there then we could drill by system, by workload, by WLM importance, and so on. So for example, let's just drill in by WLM importance level. And this is often important when you're trying to identify optimize your peak 4-hour rolling average, to identify, did I have work that could be easily, or moved to another time interval. In this case, the work is from relatively high importance levels in WLM, and so there may not be as much opportunity in this environment. All right, so now let's go back and drill in by, look at it from an LPAR point of view. And again, from here then we can drill down by workload, WLM importance level, service class, report class, or address space. So in this case, let's drill in on this system by workload, and we can see here are the workloads that are contributing, again, during that particular peak 4-hour period. We're taken immediately into that view of the data for that interval. So let's say we want to drill in by service class into the IMS workload, and here are the service classes, and then we can drill in and see, well, which address spaces were responsible for consuming that CPU. So again, if the monthly peak was substantially higher than the others, or if there's maybe some other kind of a condition that resulted in an anomaly, then we've got immediate visibility. We're not spending any time mining the data. We got immediate visibility into which workloads were consuming the CPU. All right, this slide summarizes the visibility and flexible drill down interface IntelliMagic Vision provides to analyze CPU consumption for either a peak 4-hour rolling average period or any other time frame you want to analyze. Again, the data can be viewed by KEC, by system, by workload, WLM importance level, service class, report class, or address space, and in units of MIPS, MSUs, or CPs. And this data is available both for general purpose CPs and for zips. So again, each successive drill down is right at your fingertips, only a click away, so it frees you up from the efforts to mine the data and makes the data so you can spend all your time on high value analysis activities. Now, several great capabilities emerge from the fact that IntelliMagic Vision consolidates the usage data from the Type 89 records with the address space Type 30 records. So one good use case is to enable you to profile the workload that's using a product to assist in your efforts to potentially optimize your system software stack. So here's the usage reported by various program products in this environment. So let's drill in and look at the qualifiers for the IMS product. IMS is a product that has unique components that are each separately chargeable. So we can drill into that, and here we can see the 3 components. Now if I want to look at a particular component and see which address spaces are registering that component, then I can drill in here, and now this lists all the address spaces, or actually the top 50 address spaces that registered that particular DB control component qualifier of IMS. Another, again, capitalizing on this integration of the usage data and the Type 30 address space level data. Here's just a general report that shows the top 20 jobs, batch jobs that were consuming CPU on a particular system during this interval. Then I can drill into this job, and in this section here we see the usage data, so I can see that this job registered the DB2 and IMS products. So this job would require those products to be available on that LPAR to be eligible to run on that system. And then finally, just broadening out from SCRT just as CPU usage in general. Here is, for the entire interval, here is usage for each of the processors. And again, we have all the drill downs that we talked about earlier. So we might look here and see, well, there's a spike here on this particular day, on the 18th. So let's look at that in more detail. So let's limit the interval then to just the 18th. And so we see this cumulative spike here over 5,500 MSUs. So is this typical for this time period or not? So let's compare this to, say, the previous day and see if this is representative or unusual. Okay, that represents an anomaly. I can move the mouse there and I can see that the value is substantially higher. Well, how about, is this a kind of a day of week thing? So let's look for at the previous week and compare that and say, no, again, this did represent an anomaly. And I've got other options here too. I can go back 2 weeks earlier or something like that. So again, just with that single click, again, I'm not having to spend any time mining the data. I can immediately do the analysis I want to do to say, okay, maybe there was an anomaly here, and I can drill in by service class or workload or however I want to do that. All right, so Telemagic Vision gives you great visibility into the CPU. Now, one other area of interest that's often closely connected with SCRT and 4-hour rolling averages is capping. And again, Telemagic Vision gives great visibility into the relationships between the key metrics pertaining to capping at both the capacity group and LPAR levels to enable you to analyze whether capping is having the desired effect of reducing consumption of low priority workloads without negatively impacting high priority ones. All right, so here this chart shows when WLM capping was in effect for each system on this chart, reported as a percentage of each RMF interval. So for this particular system, during these RMF intervals, WLM capping was in effect for the entire interval, and then for other intervals, just for a portion of the RMF interval. In this case, it's a 15-minute interval. All right, so let's look at it now. Let's look at capacity groups that are defined in this environment. This shows the delta between the group cap value and the 4-hour rolling average over this time interval. So the starting point of the analysis can either be this chart of available capacity, or it can actually be the group capacity values that are available on this chart. So back here, this can be a starting point for jumping off on some additional analysis, which we'll do in a second. Also, this chart in and of itself, by just looking at the negative values here, that indicates at a glance times when group capping was in effect, when the 4-hour rolling average exceeded the cap value. So let's drill into this particular capacity group. And we see that the CPU consumption in green per RMF interval is driving the 4-hour rolling average here in yellow. When capping is not in effect, the CPU can go well above the 4-hour rolling average, and that's fine. When capping is in effect, when the 4-hour rolling average is above the cap, then the CPU will be limited to the group cap value. Now we can drill in further to better understand what work is running during this that is contributing to this workload consumption. So this again is looking by WLM importance level, because dynamic capping products typically work off of the WLM importance levels, where you say these high priority workloads, I don't want them to be negatively impacted, but lower priority workloads can be. So for example, in this environment, we can see that the work all the way up through all the importance levels, including discretionary, was still, the cap value was still enough to do that, complete all that work, except during this time period when the work at importance levels 4, 5, and discretionary exceeded the cap value. Now here is an example of at the LPAR cap, at the soft cap level for LPARs rather than groups. Here again we can drill in at the LPAR level and again see the relationships between these variables. So again, here we see the CPU spiking as long as the cap is above the 4-hour rolling average. When the 4-hour rolling average gets above the cap, then the CPU consumption is limited to the cap value. And finally, we can drill into and look at the relationship between those values and also the WLM capping. So in this example, here the 4-hour rolling average in yellow was above the cap value in green during this entire interval, so WLM capping was in effect. However, it did not. The demand was such that there were, only limited periods of time when the work was actually limited by that capping because the demand was just lower than the cap level. So Telemagic Vision again is providing great visibility into the relationships between the key metrics pertaining to capping, so you can identify when capping is active and to analyze whether capping is having the desired effect that you want it to have. All right, another technology, emerging technology that customers indicate is getting a lot of traction is EDC Hardware Compression. And ZDC cards represent a new component in your infrastructure that must be managed both for capacity and performance. So ZDC hardware compression is a great application of the dashboard technology that Brent talked about earlier. So here's an example where we're going to bring together all the key metrics that you probably are of most interest to you: compression ratios, card utilization, service time, queue time, and these potential error conditions. And so again, Telemagic Vision is doing analysis of all the elements of your infrastructure and surfacing any issues that might require your attention. So we're going to come back and look at these exceptions here in a minute, but first let's just start out at hardware utilization. We again, as we drill on a dashboard, we get all the time charts or the mini charts, and we can see the utilization for this particular processor and the cards on this particular processor. We might more be interested in wanting to look across our entire environment, so just clicking up here now we see the cards throughout the entire environment for all of the 4 processors here. So then we can drill in and look by system for this particular peak and see which systems are contributing to it. And then we can also, drill in from here by card, physical channel, and do that kind of analysis. In addition to utilization, so in this environment, no cards are above 15% utilization, and so we're in good shape here. So we're also would be interested in the service times to ensure that the compression and decompression operations are not materially degrading disk response times. So here the scale is milliseconds, but these values are all have 3 decimal places. So basically we can see here that during the majority of the day here, the service times were in the 6 to 8 microsecond range. Now we can drill down here by system and look at the service times for each of the systems in this environment, or we can drill in to that service time by a physical channel, and so on. Now you remember that the dashboard showed exception values for the hardware accelerator queue times, so let's explore those. So we'll drill in here by system, and we can see that the exceptions pertain to certain systems here, which from knowing this environment those actually are either test systems or they're smaller batch systems. They're not primary production online systems. But anyway, let's look into this into more detail for this particular system. And so, just glancing across this chart, we can see that there's a minimal amount of compression activity, but there are spikes, significant spikes of decompression activity occurring on this system. So most of the activity here is decompress, and also it's very spiky. So let's look at this, drill in now to the queue times, and we can see the queue times are many milliseconds here. So those we want to understand that a little bit better. So let's compare this chart. Let's customize this chart, and in addition to looking at the queue time, let's also look at the rate of decompression activity, because again we saw that on this system it's primarily decompression activity, and since decompression activity requests per second is going to be in a different unit, not milliseconds, we'll put it on this separate axis. So I have the option to bring together any of the variables that pertain to this particular hardware accelerator set of metrics, and I can compare the relationships. So here this is very revealing, because I can see at the times when there's a high amount of activity, the queue time is basically negligible. So yeah, there is queue time, but it's not occurring at times when there are these spikes of activity. It's occurring at low activity times, and so I may not be too concerned about it. Now, typically, one of the first question that you're going to be asked by management when you implement ZEDC compression is, what is our compression ratio? So in this environment, we can see the compression ratios are typically in the 6:1 or 7:1 ratio, maybe even better. But we see an interval here around 5 p.m. when the compression ratio dipped dramatically to close to 1:1. So here's a great example of the drill down capabilities of IntelliMagic Vision. So first let's drill into that. That's at a processor level. Let's drill in at a system level and see which system was responsible for that low compression ratio. And we can see that it was this particular A5 system. Now next I would like to say, well, what jobs were running during that time that might have been responsible for that bad compression ratio? And so here we can see that I've got one particular job that did over 700,000 requests, and it was getting compression and decompression ratios just barely better than 1, and it's basically solely responsible for that activity. So I can look at that and say, well, maybe this job, whatever data it's accessing, is not suited for ZEDC hardware compression, and I'm now make an informed decision about whether I may want to remove that data from ZEDC compression. Typically, a ZEDC implementation will be carefully rolled out in a multi-stage process. So here we have visibility into how that rollout is progressing. First, this is request rates by system, and then I can drill in on a particular system and see which address spaces are responsible for those, generating those compress and decompress requests. And then I may want to say, well, for some particular address space, I may want to look at the request rate over time. So numerous other metrics are available, including request rates and throughput in and out for both compress and decompress functions. But cumulatively, this provides great visibility into ZEDC activity and performance in your environment. All right. New in the release that just came out earlier this year for IntelliMagic Vision is visibility into the TCPIP infrastructure, which critical component that provides communication both between mainframes and for traffic to and from the mainframe from other servers in your environment. Not a new data source, but may not have received as much visibility in the past from a reporting perspective. All right, so we'll select the TCPIP viewpoint, and let's go in and look initially here. Look at this dashboard. So again, another great example of a dashboard that can again be checking all the elements of the infrastructure and surfacing any areas that might be of interest to you. In this case, as we worked with the customer on this particular dashboard, this information about these ephemeral or dynamic ports was helpful information that were not previously available, so aware of in that environment. So again, that's just a great example of the value that dashboards provide. Okay, so now let's look at some of the metrics that are available. Here we see the average number of TCPIP connections by processor, and again, we can drill into this by system or by socket or by port. So let's drill into it by socket, kind of an address space construct, or we can again drill into it by port. See the average number of connections. Ports often will reflect the extent to which encrypted connections are being used, so that can be of great interest. Also, in addition to the average number of connections, the rate of connections and the maximum number of connections are available, and again, all drillable by system or by socket or by port. Let's look over here and look at the inbound multicast packets by processor. And here now we can drill into this by interface, and we can see in this environment that the traffic is well balanced between these two particular interfaces. And we also have access to channel utilizations and configuration data and so on available through for TCPIP. Talk a little bit about transaction reporting. Historically, obtaining key metrics for CICS, DB2, and IMS transactions has required processing massive volumes for many sites, often hundreds of millions or more of SMF 110 records for CICS or 101 records for DB2 or subsystem log records for IMS. And so extracting, transmitting, and processing these enormous volumes of records has typically been a very CPU intensive and thus expensive task. But now many foundational transaction level metrics are available by either service class or report class in the RMF 72 records. So this can be very helpful to make the key transaction level metrics available through this data that's far easier to process. So here are some of those key metrics: transaction rate, response time, CPU and I/O per tran, total CPU and I/O activity, and average number of concurrent transactions. So let's look at some examples of this. Here's a report of transactions executed per second for selected service classes. And again, so this can be, you can take advantage of this by mapping transactions that are of interest into either service class or probably report classes, and then process that data. And even if you say create 100 new report classes to view transactions that are of particular interest, with 15-minute RMF intervals, that still would create less than 10,000 SMF records per day compared to the tens of millions or hundreds of millions of the other more detailed records. All right, let's look at some response times. Here we see response times for many different service classes, and so we can drill in on one particular service class. And here we see the average response time, but again, average response times can often be influenced by outliers. So we may choose to want to look at this in percentile form instead. So here are the percent of transactions that were completing within, half of the goal, the WLM goal, the goal 1.5 and 2 times the goals, which in this example, the goal was 0.12 of a second. And then finally, one of the other key transaction levels metrics I'll look at here is CPU per tran. So support for populating CPU and I/O per tran data in the RMF 72 records requires CICS 5.3 for CICS and IMS 14 with a couple of APARs for IMS. So again, this can be very helpful to be able to have very accessible access to key transaction level metrics. If you need the more detailed transaction level data, like for example CISS file weights, file IO weights per transaction or something like that, then that still is going to require the more detailed processing, more detailed records. All right, and then finally to say a little bit about ZIP reporting. ZIPs now support simultaneous multithreading, which provides a capability for 2 threads to be executing per core, and so that's brought with us many new metrics. So this is kind of a general list, just to talk about a couple of them really briefly. Thread density is the average number of active threads when work is being processed. In other words, the core's not idle. There's a maximum capacity factor and the capacity factor, which are how much work the core is actually completing relative to a single-threaded core. Busy time is what percentage of the time was the core busy in either thread density, and then there's productivity, and then here we see the amount of time the core is executing in thread density 1, executing 1 thread, in the yellow thread density 2 in the blue, and then the core was idle in the red. So today we've covered several of the emerging technologies here in the right-hand column and seeing how IntelliMagic Vision can provide you very great visibility and accessibility into this data. So now I'm going to hand it back over to Brent.
Okay, thank you, Todd. I'm going to switch my screen there. Okay, so we wanted to talk just a little bit about what's involved in sending us some data and seeing this for your particular environment. So it's one thing to see a demo, and we just didn't have time obviously to go real slow and do a deep dive into any particular area that you might be interested in. But you can do that with your own data if you want to take advantage of the proof of concept kind of offer that we have. There's no charge available, and we'll also have some of our consultants spend some time with you to kind of accelerate your learning of what you're looking at and how to use it, and in particular even for doing some assessment. So Todd is one of the experts in the country on reducing MLC, for example. We have some unique visibility that other products do not have in the MLC assessments because we're calculating some additional metrics and so on and so forth. So you can actually learn more about that. In particular for the processor cache efficiency topic, there's some resources on our website. I'll give you a link here in just a minute. You may want to look into that. But it's pretty simple to just FTP us some data. We have a program called RMF Pack that we'll send you. We'll load it in and prepare it, and that's the best way to understand what's the difference with this kind of approach to understanding what the RMF and SMF data means for your applications and your infrastructure. We did talk about questions. We're really just about out of time right now, so but please go ahead and submit additional questions if you have more, and we'll get back to you in writing afterwards. Here's the links I was talking about. So you may be focused on one particular part of the infrastructure in your environment. These are just some quick links, and again, you will get a copy of this presentation by email once we're done. So this will be there, but it's pretty easy to remember as well if you just want to drill into more information about any of these particular areas. So with that, we are actually at the top of the hour. So I think we'll go ahead and wrap it up now, and then go ahead and send some more questions. We have some people submitting questions. And let me just answer this one of these real quick, because I failed to mention on the different product modules that we have. You don't have to license the entire product if you want to just start with the disk storage, or we have this also for virtual tape, where we're comparing the hardware characteristics with your workloads and surfacing any particular areas that need attention, that are starting to get stressed in that environment. Or on the system side, network is kind of our newest module. Todd showed you some of the TCPIP reports. The summer release has MQ capabilities coming out in it, and so on and so forth. So generally the proof of concept is on the whole scope of the infrastructure that we support, but you don't have to license the entire product suite if you really only want to start with some metrics for any particular portion. All right, well, thank you for your time this morning, and we'll send some follow-up emails. Thank you, Todd. Bye-bye.